Hello, good day everyone. I am Joshua James Nolledo together with my groupmates Cortiñas Laidee, Hernandez Danisse, Martinez Shara Lee, Malabanan Laidee Angelica. We are going to present our case study number 2 entitled Reliability Centered Maintenance or RCM of a Commercial Heating, Ventilation, Air Conditioning or HVAC Air Handling and Condensing Unit. For the content of our study, we have the introduction, followed by the problem and evaluation, implications, followed by recommendations, and lastly, the conclusion and summary. For the introduction, Reliability-Centered Maintenance or RCM is a process to determine the maintenance requirements of any asset machinery under its optimal operating conditions. The strength of RCM lies in the fact that it can be applied to any process no matter its size. Furthermore, RCM can be used to develop scheduled and proactive maintenance procedures, redesigning of equipment, improving troubleshooting procedures, hence increasing the overall efficiency of the process and reducing its cost. Therefore, RCM is a structured process that is used to determine the failure modes and develop strategies to overcome them under operation requirements and effective costs. Recently, a forensic laboratory has been set up by the Sindh government at Karachi University, whereas as per Forensic Laboratory Handbook, air handling units have been installed to provide filtered, conditioned air so that the working environment can be maintained as per user specifications. A total of 10 air handling units have been installed across different labs in the forensic facility. 2 critical labs have 100% redundant HVAC systems, 2 air handling units paired with condensing units that are connected to the building management system, which continuously monitors both the system that is running on the standby. In case one unit breaks down, it automatically shifts the other one and vice versa. The BMS system makes sure that the laboratory is available for 24 hours a day, even if the HVAC system breaks down. So the purpose of AHU HVAC system is to maintain the temperature, humidity, and differential pressure of a certain zone within the desirable limits, and it comprises the 3 main components, namely the air handling unit or the AHU, condensing unit or the CUN, and the thermostat box. For the air handling unit is an assembly of different components that are divided into the following sections. We have the return air mixing section, aluminum filter section, the 65% bag filter section, motor and blower section, cooling coil, 95% bag filter section, and the discharge plenum. The supply return air sections of the AHU are connected via ducts to supply condition and filtered air to the respective zone. The room air is pumped into the return air mixing chamber of the AHU, where some fresh air is added, fresh air that is connected to the return air mixing chamber. This mixture of return and fresh air then passes through the series of 3 filters, which is the aluminum pre-filters, the 65% bag filters, and the 95% bag filters. After the initial filtration process, the air is pumped into the blower section, where a motor is connected to a centrifugal blower via belt and pulley arrangement. After the blower section, the air is expanded by the diffuser plate so that it can travel uniformly through the cooling coil. The cooling coil cools the humidifies the incoming air so that the temperatures can be achieved. After the cooling coil, the air passes over 55% filters, which removes the fine particles suspended in air. Then finally, the air is pumped into the discharge plenum, which is connected to the central ducting system. The filter then and conditioned air then enters the particularly zone and differential pressures. So next would be the condensing unit or the CUN. The CUN are responsible for pumping heat from low temperature reservoir to a high temperature reservoir. They consist of the following major components. First is the compressor, condenser fan motor, condenser electric, the refrigeration component accessory. So condenser is designed to exchange heat between the working fluid and the atmosphere. The basis of working of a condensing unit is a simple vapor cycle. The gaseous run is pumped by the compressor such that it has a higher temperature than the surrounding atmosphere. So this heated refrigerant is pumped to the compressor coil where forced air ventilation then by condenser fan motor allows the refrigerant to reject heat to their surroundings. The refrigerant rejects all the latent heat and becomes saturated liquid. So this liquid is throttled to a low temperature and pumped into the AHU where it cools the surrounding air by absorbing the heat and becomes saturated vapor. So this vapor is then passed to the compressor and cycle continues. So next would be the thermostat box. So the thermostat box serves as the brain control unit in the entire HVAC system, providing communication and seamless control between air handling unit and condensing unit unit to ensure the operation in different weather conditions. So this thermostat box consists of temperature sensors, AHU starter relay, compressors, start relay, condenser fan, motor start relay, high and low pressure relays, LCD, screen, control circuit. So the thermostat or the operation box controls the entire operation of the HVAC system. A temperature sensor is located in the return air duct of the HVAC system, and it's connected to the thermostat, which regulates the room temperature by turning off the compressors as required. The room temperature and fan controls are just adjusted via thermostat. Moreover, the thermostat can display different error codes for the problem such that AHU coil sensor failure, insufficient of or loss of refrigerant compressor overload, low and high refrigerant pressure, AHU coil freezing, and etc. Whenever an HVAC unit trips abnormally, the corresponding error is displayed on the thermostat box, which helps the technical staff in diagnosing the problem immediately and accurately. Moving on, so this figure or graph represents the diagram showing the problems in this case. So the integrity of the experiments as well as the safety of the health of laboratory personnel depend on the proper ventilation. So it makes sure that the dangerous chemicals and materials are taken out of the lab and that the fresh air is introduced. So to maintain a safe and healthy environment for lab workers, proper ventilation in the lab removes hazardous materials and chemicals and brings in fresh air. So for the lab workers, inadequate ventilation can result in health risks like respiratory issues and chemical exposure, as well as the compromise the validity of the experiments. Thus, it is duly essential to maintain the ventilation equipment, including the HVAC systems. So now, this paper aims to attain the set of objectives in line with the application of the reliability-centered maintenance in improving solutions and recommendations regarding the functional failures of HVAC system components. Specifically, so this case aims to fulfill the following objectives. First is to utilize RCM information sheets in presenting the failure modes and effect of the HVAC component's functional failure. Second is to evaluate the implications caused by the function failure of the HVAC system. Third would be to utilize the methodology of RCM decision worksheet to propose necessary actions. And the last one would be to propose a maintenance strategy.
Next is the problem and evaluation. The individual functions of AHU, CUN, and thermostat box are defined along with their functional failure, which describes the loss of function. Some major failure modes of each component are discussed along with their failure effect on the operation of the laboratory. For the air handling unit, the air handling unit functions as the filter, cooler, and air pump throughout the central ducting system. Functional failure occurs when the AHU stops supplying conditioned air to the respective zone. It could be caused by a broken fan belt, leakage in the evaporator belt, and burnt motor. In addition to wasting energy in lowering indoor air quality, leaks or gaps in outdated or improperly installed ductwork can result in drafty or warm spots in establishments. Also, any ongoing processes or activities requiring a conditioned environment will have to eventually stop, which will result in financial loss. Next are the condensing unit. Condensing unit is responsible for rejecting heat into the surrounding air and supplying cool refrigerant to the AHU for heat exchange. When heat rejection in the environment and vapor compression cycles stop working, functional failure occurs. The cause of this function failure includes compressor failure, coil leakage, and fan motor failure. Less heat can be transferred from the refrigerant to the ambient air if the mentioned functional failures in the condenser unit occur. Thus, there will be a loss of cooling and dehumidification in the area. Temperature and humidity will not be maintained, hence the lob will become unavailable. Next are the thermostat box. Since the operation box controls the entire operation of the HVAC system, the possible function failure to this is its inability to control its counterparts. These may be caused by circuit failure. If the thermostat malfunctions, the HVAC system may start and stop randomly. As a result, rooms closer to the HVAC system receive more cool or hot air, while those farther away receive little or either.
Moving on to the implications, function failure in the components of AHU HVAC system will result in the loss of temperature, humidity, and differential pressure, resulting in unavailability of lob. If there is any process going on which requires a conditioned environment, it will be stopped, which will result in financial loss and unexpected downtimes. Next. As per the original equipment manufacturer, the cost of a common spare part of an AHU-based HVAC system is shown in this table too. And as you can see, starting from the contactor for compressor until the low pressure control, we have a total amount of 116,000 pesos. Next. Currently, there is no preventive measurement schedule being followed at the forensic lab. The entire facility is on the run to failure maintenance, which means when a particular equipment breaks down, technicians are called to resolve the issue. This incurs higher costs and unavailability of lab during breakdown, which causes unexpected delays in the decision of court cases. However, if the proposed maintenance strategy, which is discussed previously, is followed, then we can ensure 24/7 lab availability and save costs from the following scenarios. First, chocked filters and clogged coils can reduce efficiency of HVAC systems with respect to pumping and efficient heat transfer of return air. The chocked filters increase static pressure drop in the air handling unit, which increases the motor current to the point that airflow starts to decrease in the central ducting system and a loss of cooling or heating occurs. Similarly, when a coil is clogged, heat transfer is reduced, and the air is not cooled or heated up to the design specifications. The combined effect of chocked filters and clogged filters can reduce overall system efficiency by 13 to 15% and increase electricity bills correspondingly. This case study was carried out by Goodway Technologies Corporation, which provides cleaning solutions for HVAC systems. And if coils are not washed periodically, the dust clogging the coils combines with the moisture in the air and starts the pitting process until the refrigerant circuit leaks. And if the refrigerant circuit leaks, then repairing it will incur a total cost of 67,100 as indicated in table number 3. Next.
So for the recommendation, an air handling unit-based HVAC system is a complex machine that requires periodic maintenance of its component to ensure smooth function. A complete preventive maintenance procedure must be developed and discussed in detail. The methodology for the RCM decision worksheet shown in this table has been obtained from the Reliability-Centered Maintenance by John Mowbray. Furthermore, values used in this column for the failure function are FF and FM for the failure mode are referenced in Table 1. RCM is a process to determine the maintenance requirements of any asset or machinery under its optimal operating conditions. It is a process that is completed to make sure that all the machinery and assets perform as desired by their users with optimum efficiency. The strength of the RCM lies in the fact that it can be applied to any process, no matter its size. RCM includes reactive, time-based, condition-based, and proactive tasks. In addition, a user should also understand system boundaries and facility envelopes, system or equipment functions, functional failures, and failure modes, all of which are critical components of the RCM program. This table, it shows the proposed maintenance strategy that arose in the analysis and evaluation of the problems or issues occurred in this situation. For the component of air filters, the maintenance procedure includes the clean filters with a vacuum cleaner tap, the filter on a soft surface, then rinse the filter with a detergent and warm water, then rinse well and dry the filters before the reinstallation in the air handling unit. For the recommended schedule, at least every 15 days. If environment is dusty, do it more frequently. For the bag filters, for the maintenance procedure, measure the differential pressure across the bag filters. If pressure exceeds 1.2, replace the filters immediately. For the recommended schedule, check every 2 months. If the environment is dusty, check every month. For the evaporator and condenser coils, use a high-pressure washer to clean and remove any dirt that is clogging the coils. And it should be checked every 2 months, more frequently if the environment is dusty. Next, for the condensate, drain pan, and pipe, check for any blockage and clean the drain pan. And it should be done after every 3 months. For the condenser fan, check for any unusual vibration and noise. Check that mountings are in place. And it should be done every 2 months or as required if any problem is detected. For the evaporator fan, check for any unusual vibration and noise. Check that the fan rotation is correct and check and replace damaged belts. For the recommendation, it should be done every 2 months or as required if any problem is detected. For the fan motors lubrication, motors are lubricated and sealed at factory. Therefore, no maintenance is necessary unless the motor is open. For the electrical, monitor voltage, current, and wiring. Check for loose connections and worn-out contacts and make sure all connections are tightened. It should be done every 2 months. For the compressor lubrication, if there is a leak in the refrigerant piping, check oil level, otherwise it is not necessary. And check if piping has leaked. For the refrigerant piping, check leakages at joints and check in order to keep the HVAC system in working condition and assure 24/7 lab availability. It is important to follow a preventive maintenance schedule as discussed in Table 4. Furthermore, after an extended shutdown, make sure to follow the steps described below. First is make sure all above maintenance procedures are performed. Make sure the evaporator and condenser fan rotation is in the correct direction. The compressor's crankcase heater should be turned on 24 hours before starting the HVAC system. However, in case of scroll compressors, there are no crankcase heaters. And lastly, check circuit.
Conclusively, this case study number 2 revolved around the reliability-centered maintenance of a commercial heating, ventilation, and air conditioning system. It has presented a case of a forensic laboratory with 2 air handling units paired with condensing units connected to the building management system, which continuously monitors both the running system and one on standby. So with the use of RCM information sheet, the needed information for each component of the HVAC system was presented along with the function failure of the component and its failure mode. Also, the information sheet includes the possible effects caused by the function failure. So to provide a solution to this, the proponents use the RCM decision worksheet, which aids in assessing the frequency of the necessary maintenance of each HVAC system. So further, the results from the worksheet aided the formulation of the proposed maintenance strategies that must be implied by the forensic laboratory. Thereupon, it can be concluded that practicing the reliability-centered maintenance of the HVAC system on a regular basis will ensure the smooth operation, prevent breakdown maintenance, and extend the life of the equipment if the recommended maintenance procedure is followed. So this brings me to the end of our presentation. Thank you and God bless.